if you step outside today, and just look up at the sun, well, don't look directly at it, obviously. But if you do, you aren't actually seeing it as it is right now.
Right, yeah. You're seeing it as it was, what, roughly 8 minutes ago?
Exactly. 8 minutes ago. And, physics has known about that delay for a very long time. It's just a fundamental truth of how light travels.
Yeah, light speed is fast, but it's finite.
Right. But what if I told you that by failing to, fully grasp the true structural implications of that simple visual delay, theoretical physics has actually been using a completely broken map of the universe for over 100 years.
It sounds almost like heresy to modern science, right? But the argument we're looking at today is incredibly compelling.
It really is.
Because when we ignore the actual mechanics of how an observer acquires information, how we actually see things, we end up inventing these phantom forces to explain away the mathematical contradictions that just inevitably pop up.
Which brings us to the show. Welcome to this deep dive. Today we are opening up the stack of sources you sent over, specifically this fascinating draft document called timekagura.pdf.
Yeah, and the really dense analytical dialogue that came attached to it.
Right, we've got both. And our mission today is to explore a radical reinterpretation of Einstein's special relativity. But to be clear for everyone listening, this is not, some dry walk through complex equations.
No, not at all. It's really a fundamental, almost philosophical shift in how we observe the physical universe.
Yeah. The author's core premise is that modern physics just fundamentally confused different types of spatial perspectives. And as a result, they had to invent these bizarre tricks like time dilation and length contraction just to force the math to work.
Exactly. Patching the math rather than fixing the math.
Okay, let's unpack this. Because to understand where physics went wrong, we really had to start with the map itself, right? The Cartesian coordinate system.
The good old standard X, Y, and Z grid.
The one from high school geometry.
Right, yeah. René Descartes supposedly came up with it while he was, lying in bed watching a fly crawl across his ceiling. He realized he could describe its exact location using intersecting lines.
Which is brilliant for ceilings.
Totally. But the document argues there is a massive foundational error in how modern theoretical physics uses that Cartesian space. The author claims there are actually 3 distinct ways to understand this coordinate space.
3 ways?
Yeah, and traditional theoretical physics has just recklessly blended the first 2 together.
Okay, so let's break down those first 2. Number 1 is what the author calls mathematical space, or the God's eye view.
Right. So imagine looking at that 3-dimensional XYZ grid from completely outside of it. You aren't a physical person standing inside the grid, right?
Or like a ghost hovering over it.
Exactly. You are this omniscient theoretical observer looking down at the entire universe all at once. In this purely mathematical space, the grid goes on infinitely.
Okay, makes sense.
But more importantly, you assume that a simultaneous now exists everywhere. Time is treated as this constant flat plane. You assume that if it is 12 p.m. at your exact location, it is instantly 12 p.m. on the literal opposite side of the galaxy.
Right, because you can see the whole board at once.
Precisely. That's the God's eye.
And then we have the second type of space, which the author calls experimental space, or the camera eye. And this is where the trouble actually starts, isn't it?
Oh, absolutely. Because the camera eye is the total antithesis of the God's eye.
Right. In the camera eye, the observer is a physical entity located inside the space. You are at a specific coordinate, let's say, 0010.
Yeah, you're trapped on the board.
Exactly. You're trapped inside the grid, which means physical distances suddenly really matter. The literal time it takes for light to travel from an object to your physical camera lens or your retina, that becomes the absolute limiting factor of your reality.
And the central thesis of the Timekagura document is that theoretical physics took that first concept, the omniscient God's eye mathematical space, and incorrectly forced it onto the physical camera eye observation space.
Think of it like a video game. I love this analogy. The God's eye view is like the game engine running on the console itself, right?
Right, the background code.
Yeah, the code knows the exact coordinate of every single enemy, every item, every tree on the entire map simultaneously. The engine possesses a universal now.
It sees everything.
But the camera eye is the player experiencing the game in first-person mode. The player cannot see the whole map. They only see what the code renders on their screen right at this exact second.
Based purely on their limited line of sight.
Exactly. Line of sight and, the speed at which the graphics load. The player never actually experiences the engine's universal now.
What's fascinating here is that the author claims if we properly structure our physics around how an observer, the player in your analogy, actually acquires that delayed information, the so-called tricks of Einstein's relativity just disappear entirely.
They just vanish.
Yeah. Space-time isn't bending. The geometry of how we acquire delayed information simply creates the illusion of a bend.
But wait, let me push back on that for a second, because, I mean, Einstein's math works.
It does work, yeah.
The GPS satellites orbiting the Earth right now, they literally rely on calculations for time dilation to keep our phone maps accurate. So if the math of relativity is functioning perfectly in our everyday technology, how can this author claim the entire concept is just some patchwork illusion?
Well, because the math being functional doesn't mean the ontological explanation for why it works is actually correct.
Okay, fair point.
Think about how physics responded when their God's eye equations didn't match the camera eye observations. They didn't change the underlying map, right? They invented physical phenomena to bridge the gap.
Oh, like Lorentz contraction.
Exactly. Take Lorentz contraction. To make the equations balance out, physicists propose that as an object moves faster, the actual physical matter of that object literally shrinks in the direction of motion.
Like a ruler physically getting shorter.
Right. But the author is arguing that the ruler isn't physically shrinking at all. The discrepancy is purely an artifact of measuring a moving object using delayed light while falsely assuming you're in a God's eye instantaneous grid.
So we mathematically patched the discrepancy instead of just, fixing the underlying spatial geometry.
Yes. We put a Band-Aid on a broken map.
That fundamentally changes how we have to think about observation. Because if that omniscient God's eye view is physically impossible for a human being to actually experience, what is the actual shape of our reality?
Right, like what does the physical world actually look like to the camera eye?
Yeah.
Well, the author posits that actual observation is not a flat plane of simultaneous existence. It's what they call a spherical screen.
A spherical screen. Okay, let's visualize that. When you physically open your eyes, light hits your retina all at the exact same simultaneous fraction of a second.
Right. It hits you all at once.
But that light is a chaotic mixture of completely different travel times.
Exactly. We mentioned the sun being 8 minutes old, but think about the rest of your view. The tree outside your window is, nanoseconds old.
Right?
The stars you see at night are millions of years old. Yet, every single one of those different light beams hits your eye at the exact same moment on your retina.
That's wild to think about.
It is. Therefore, as an observer, you never actually experience a simultaneous now. You are trapped inside a spherical screen that's constantly displaying this mosaic of different fragmented paths that are just now arriving at your present location.
So when I just look across my living room, my brain is taking all of these highly fragmented, delayed light signals from different moments in the past, and it is actively stitching them together.
Yep, your brain is a master editor.
My brain is creating this comfortable, seamless illusion that everything in the room is happening right now.
The author asserts that simultaneous time, the concept that things are happening right now across a flat plane of existence, is purely a reconstructed memory.
A reconstructed memory. Wow.
Yeah. It is a psychological convenience, not a physical reality. We take delayed information, we process it, and we mentally construct a theoretical now just to make sense of the world. But out there in the physical universe, that instantaneous plane simply does not exist for the observer.
Okay, but if this delay is so fundamental to how everything works, how did an entire century of brilliant physicists just miss it?
Well, the document points directly to the famous Michelson-Morley experiment as the sort of original sin here.
Right, the ether wind experiment.
Exactly. Late 19th century. Physicists wanted to measure the ether wind, this theoretical medium they believed light traveled through, so they built an interferometer.
Which is basically a device that splits a beam of light, shoots the two halves in different directions it mirrors, and measures how long they take to bounce back.
Right. And since the Earth is hurtling through space, they assumed the light beam traveling in the direction of the Earth's movement would fight a different wind than the beam traveling perpendicular to it.
Like swimming upstream versus swimming across a river.
Exactly. Perfect analogy.
But the experiment resulted in a null finding. The light beams always came back at the exact same time, no matter which way the device was pointed.
Right, and the contradiction arose because they treated a moving, local camera eye as a stationary God's eye.
Oh, I see.
The experimental setup was on Earth, right? Revolving around the sun, moving through the galaxy. But they evaluated the light bouncing between those mirrors as if the interferometer were an absolutely stationary focal point within a universal God's eye grid.
So they didn't account for their own movement in the big picture.
Because they failed to account for the fact that the experimental frame itself was already moving within a broader global system, the math showed a massive discrepancy.
And to solve that discrepancy, they applied those Lorentz contraction patchworks we talked about.
Yep. They mathematically shortened the physical arm of the interferometer just to force the data to make sense.
Unbelievable. So if the old grid is fundamentally broken because we are, always moving and always dealing with delayed light, what tool can we possibly use to measure distance?
We need a new map.
Yeah, we have to throw out the Cartesian map. We can only measure the universe by the one thing that actually touches us, the flow of information itself.
Which requires moving to the third type of space in the author's framework, the shared information space. And this relies entirely on the concept of the past light cone.
The past light cone. The author specifically targets Hermann Minkowski in this section, right?
Oh, heavily.
Minkowski was the mathematician who took Einstein's theories of relativity and formalized them into those space-time diagrams that physics students still use today.
Yeah, and Minkowski spacetime is an incredibly elegant geometric model, don't get me wrong. But the author identifies a fatal flaw in how we interpret it.
What's the flaw?
Well, in a standard Minkowski diagram, you have a vertical axis for time and a horizontal axis for space. Minkowski drew the past and the future as flat horizontal planes stacking up along the time axis.
Okay, like layers of a cake.
Right. But the critique is simple. How can an observer who is just a single isolated point existing in the present possibly have access to an entire flat horizontal plane of the universe?
They can't. They literally can't. They only have access to the specific light beams that have finally hit their spherical screen.
Exactly. So the author proposes completely redrawing space-time to reflect that limitation. Instead of an x-axis for space and a t-axis for time, where time is treated as a flat plane, you place the camera eye observer dead at the center of the map.
Okay, so I'm in the middle.
You're in the middle. And instead of using simultaneous time, you redraw the grid using light travel time as the universal constant.
Here's where it gets really interesting. Because when you redraw the map using light travel time as the constant, space-time is no longer a grid of squares. It transforms into a series of concentric circles, or I guess concentric spheres in 3 dimensions.
Yes. Spheres of information.
Right. So a circle with a radius of 1 represents all the events in the universe that are exactly 1 unit of light travel time away from your camera lens.
You are mapping the universe by causal reach rather than physical distance.
It's like standing in the middle of a massive pitch-black pond where someone just dropped a handful of pebbles all over the water.
Oh, that's a great way to look at it.
Thanks. Like in the God's eye view, you'd be hovering above the pond with night vision goggles, seeing every single splash the exact fraction of a second it happens.
Right, seeing the whole thing at once.
But in the camera eye view, you are standing waist deep in the water in total darkness. You have absolutely no idea a pebble dropped until its specific ripple finally travels across the water and physically hits your legs.
You map the pond strictly by recording the exact arrival times of those ripples.
Exactly. That's the only reality you have.
And that pond analogy perfectly illustrates the author's concept of a certainty distribution.
Certainty distribution.
Yeah. Space is not a geometric empty box waiting to be filled with objects. Space is a distribution of information certainty. Think about your ripples. A ripple that hits your legs from 10 feet away carries clearer, more robust energy than a ripple that originated 100 feet away and slowly lost its energy traveling to you.
Oh, right. It gets weaker.
Exactly. The information arriving from a light travel radius of 10 is fundamentally more certain than the information arriving from a radius of 100. We are not mapping physical stuff. We are mapping the certainty of delayed signals.
The document draws a really unexpected parallel here, too, between Einstein's work on relativity and his earlier work on Brownian motion.
Yeah, the 1905 paper. Brownian motion refers to the random, erratic jittering of microscopic particles like pollen floating in water.
Right.
In 1905, Einstein proved that this jittering was caused by invisible water molecules constantly crashing into the pollen. To prove this, he took Newton's classical macroscopic mechanics and applied them to microscopic statistical phenomena.
He bridged the big and the small.
Exactly. But the author argues that Einstein did the exact same structural thing with relativity. He took Descartes' classic macroscopic God's eye Cartesian coordinate space and simply extended it into the invisible microscopic electromagnetic field.
So he essentially took a mapping system designed for, drawing lines on a ceiling and stretched it over the transmission of light through a vacuum.
That's the argument. The Time Kagura document argues we need a total paradigm flip. We cannot treat the electromagnetic field as just another Cartesian box. The universe organizes itself purely by that causal reach when the ripple finally hits the observer.
And this raises a huge logical problem for me.
Okay, let's hear it.
If I am standing in my dark pond feeling my ripples, and you are standing 50 miles away in your dark pond feeling your ripples, we are both locked inside our own personal, isolated bubbles of incoming light.
True.
If simultaneous time is just a biological illusion and we're all just processing delayed ripples, how is science even possible? Like, how do we ever communicate or agree on a shared, objective reality?
That is the big one. This raises such an important question, and honestly, it explores the most profound philosophical territory in the whole document. How do we bridge the gap between isolated observers?
How do we do it?
Well, the author points out that when there are two observers, the only reality they can possibly share is the exact intersection of their past light cones.
The places where our ripples overlap.
Exactly, the overlap. But the mechanics of those overlapping ripples create a secondary problem. Because observers are constantly moving through space, the light reaching them has an apparent velocity.
Apparent velocity. What does that mean in the pond?
Think back to your pond. If you start walking forward through the water, the ripples hitting you from the front will feel faster and more frequent than the ripples hitting you from behind.
Oh, sure, because I'm walking into them.
Right. So if you want to calculate exactly where the pebble dropped, you have to know precisely how fast you are walking relative to the water itself.
I need a baseline. I need some kind of broader reference frame to anchor my math.
And to make those calculations in physics, we require what the author calls a global electromagnetic field coordinate system.
A master grid.
We need a master grid, but the paradox is that this global coordinate system cannot be directly observed by anyone.
Because we're forever trapped inside our camera eyes. So we are completely stuck. We desperately need a master grid to agree on reality and do physics, but we are physically incapable of ever seeing the master grid.
This is where the author introduces a stunning concept, applying Pascal's wager to theoretical physics.
Wait, Pascal's wager? Like the philosophy concept?
The exact one. Blaise Pascal was the 17th century philosopher who argued that human beings should bet on the existence of God.
Right, because the potential infinite upside of being right far outweighs the finite downside of being wrong. You took the wager because it's just the most functional, practical choice.
Right. Applying that logic to physics, the author states that because we cannot observe the global coordinate system, observers must make a calculated functional gamble.
We just guess.
More than guess. We pool our past observations, we trust the delayed information arriving from other observers' light cones, and we collectively, consciously agree to assume a shared coordinate system exists.
Wow.
We take a wager to make the math work. The author even refers to this as a necessary delusion.
So we literally hallucinate a shared grid simply because it is the only way our species can function and do science.
That's the claim. The author uses a multi-layered analogy to illustrate this wager. Imagine the Cartesian coordinate space, that rigid mathematical God's eye grid, as the solid ground.
Okay, the ground.
Now imagine the electromagnetic field, the actual physical medium of the universe, as the air. In this analogy, light is sound traveling through that air.
Okay, let me unpack that. If we want to measure how fast sound travels between two people standing on the ground, we have to account for the wind, right?
Right.
If the wind is blowing hard, it changes the travel time of the sound.
Exactly. And to make any reliable mathematical calculations about the universe, to establish fundamental laws of physics, we have to assume a windless state.
A windless state.
We have to gamble that the air is perfectly still relative to the ground. We make a Pascal's wager that our framework is stable, even if deeper, infinitely complex, windy layers of reality exist that we just cannot observe.
So we willfully narrow our lens.
Yeah. We take the wager just to be able to describe the physical phenomena around us without all the equations collapsing into total chaos.
That makes the laws of physics sound incredibly subjective. It feels more like, I don't know, a negotiated treaty than an absolute truth.
It's definitely a shift in perspective.
Which leads me to the biggest variable of all, the speed of light. The famous c in Einstein's E=mc². Is the speed of light an absolute structural pillar built into the fabric of the universe, or is it just a byproduct of this wager we are all making?
If we connect this to the bigger picture, the author's stance is definitive. In this model, the speed of light is not some magical structural boundary of empty space.
It's not.
No, rather, it's an emergent quantity. It's dictated by the structure of how information is transmitted and observed. It represents the absolute physical limit of information transfer across those intersecting light cones.
It is simply the maximum speed of the ripples in the pond.
Precisely.
So what does this all mean? Let's take a step back and look at the massive paradigm shift this deep dive is proposing. We're being asked to fundamentally stop viewing the universe as a giant, pre-existing, empty box where events happen simultaneously on an invisible grid.
Yeah, that God's eye view is just a mathematical fantasy.
It demands we abandon the map that has guided us for centuries.
Which is hard to do.
Very. Instead, we have to start viewing the physical universe as this decentralized, chaotic network of information. A web constructed entirely from delayed light signals crashing into our individual camera eyes.
Beautifully put.
And if the Time Gagura document is correct, the mind-bending paradoxes of Einstein's relativity, the shrinking rocket ships, the slowing clocks, they are not physical realities of a bending universe.
No, they're artifacts.
They're the artifacts of human beings trying to force the wrong map onto the right territory.
We spent a century bending the physical territory to justify a rigid, unobservable map.
And it all culminates in that wager. The unsettling realization that everything we collectively agree on as real or simultaneous is just a highly functional, practical gamble we take to survive the delay.
A necessary gamble to make sense of the delayed light hitting our spherical screens. But, it leaves us with a rather haunting, lingering question.
Oh, let's hear it.
Does an objective, simultaneous now actually exist anywhere in the universe? Consider the architect's blueprint of reality, where you can point to a coordinate and declare exactly what is happening in this exact fraction of a second.
Right, the master grid.
If this framework holds true, that blueprint is entirely fictional. It means the reality you are experiencing in this precise moment, processing the sound of this very sentence is simply an isolated, localized memory in the making.
Wow.
It is a moment of reality that the rest of the universe won't even agree upon until the light from your location finally reaches them long after you are gone.
That's heavy.
Are you living in a physical, simultaneous universe, or are you simply floating in a universe constructed entirely of delayed information?